James's definition of intelligence, which is the ability to reach the same goal by different means. It's what I like about it. It's very cybernetic. It doesn't talk about brains or being evolved or designed or anything like that. It talks about what is universal and common to all examples of intelligence, which is the ability, a degree of competency to solve a particular problem in novel circumstances. So he actually had this beautiful example of the difference between two magnets trying to get together and Romeo and Juliet trying to get together. And the reason that all of these are on the same, I mean, they sound like very different things. Of course, we're not used to thinking about them in the same way, but there's a continuum here, which is this, the ability to deal with barriers in your navigational space. So these two magnets are neither of these magnets is competent to go around the barrier and get together, because in order to do that, you would have to temporarily get further from your goal. And these things, they're so simple. All they're doing is trying to minimize the free energy. And so they're never going to temporarily step away in order to get where they need to go. Of course, here you have huge competencies and planning and all kinds of things. But in between, you have all of these other things. You have autonomous vehicles and cells and worms and animals that have different degrees of competency to navigate around barriers in their space that stand between them and their goals. And we can try to quantify that in different types of unconventional systems. So let's ask, okay, given this kind of definition, the ability to get to the same goal by different means, what kind of competencies do cellular swarms have? This is normal development. Normal development is very robust. So you start with an egg and you end up with a person. Almost always, it's quite robust. However, what we find out is that it's actually not hardwired, because if you cut this embryo into pieces, and you can cut them into a number of pieces, you don't get half bodies. You get perfectly normal monozygotic twins. So this system, if you deviate it from its normal starting position, it doesn't just go to the incorrect location. It's actually from different starting positions. It's able to navigate to that same ensemble of goal states that corresponds to a normal human organism. It has the ability to avoid local minima and so on. So this idea of being able to get to that same location from different starting positions. So we can start here and we need to regenerate all of this, or we can start here and we only need to regenerate that. That's the ability to get to the same goal from different paths.